I'm Balaji, final year Triple E, and now I'm here to teach about time and distance in the aptitude. First of all, welcome you all to this online training program conducted by Pondicherry Engineering College Training and Placement Cell. So let's get started. In today's topic, we have time, distance, and work. Work is eliminated because it is a vast syllabus. Time and distance is also a vast syllabus. So we are covering only time and distance today. Time and distance, we have three categories. One is problems related to car, cycle, or man, and second type is problem related on trains. And this trains problem is most important. Nearly 90 to 95% of questions comes from train problems. And the third important thing is both and streams. If you see here, the car, cycle, and man problems and the train problems are mostly similar to each other. 95% they are similar. But when it comes to boats and streams, it is entirely different from these two concepts. Okay, so let's get started. So first of all, before moving into the topic, we must understand some basic formulas. So the important formula here is speed equal to distance by time taken. This we have learned in our early classes itself. So 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 we are going to first discuss about time. What is time? In a problem, when you face when someone gives time, and you must know the representation of example. For example, if 1 minute is given, it is 60 seconds. For 1 minute, we have 60 seconds. For 5 minutes, we don't know how many seconds. So we must use this cross rule. Listen here, how you must use. Just write 1 minute is equal to 60 seconds. Okay, and the 5 minutes is equal to x second. So if you cross multiply this, x into 1 equal to x, and 5 into 60 is equal to 5 into 60, which is equal to 300 seconds. So for 5 minutes, we have got 300 seconds. And the second thing is, see here, 1 minute is equal to 60 seconds. Then for how many minutes is 120 seconds? Again, apply the same cross rule. 120 into 1 is equal to 60 into x. Now what is x? X is equal to 120 by 60, which is 2 minutes. So to get a lower value from higher value, we must multiply, and to get higher value from lower, we must divide. Okay, I hope you understand. And the same thing for 1 hour is 60 minutes. 1 hour equal to 60 minutes. And what is 2 hour? 2 hour is for 2 hour is how much? 2 into 60, which is equal to 120 minutes. The same is that 1 hour equal to 60 minutes and x hour equal to 30 minutes. So 60x equal to 300. So x equal to 300 by 60, which is equal to 5 hours. Suppose in a problem, if they give like this 5 hours 30 minutes. So how you represent here? Either you convert this 5 hours into minutes, or you convert this 30 minutes into hours. Okay, either way you can do. So see here, 5 hours 30 minutes. Now we are going to convert only this minutes into hours. So 30 minutes is how many hours? So 30 by 60. As we have discussed here, here we see xr equal to 300 minutes. Then what is that x equal to 300 by 60? The same we are applying it. 30 minutes divided by 60. We are here we are getting 5.5 hours. So to remember this, dash a shortcut. Okay, put a clock like this, and for 15 you put 25, and for 30 you put 50, and 45 you put 75, and for 12 you put 100. Okay, if take this example, 5 hours 30 minutes, and where 30 lies in 50, so it is 5.50 hours. The same way take 5 hours 15 minutes. So same way take 5 hours 15 minutes. 15 lies where? 25. So 5 hours 25 minutes. The same way is 3 hours 45 minutes. 45 is 75. So 3.75 hours. Okay. Do people understand? Manish, did they understand? Is there any doubt? If they understand, if there is any doubt means I shall clear. Yeah. Okay. Shall I continue? Yeah, okay. Okay. And the second thing we are going to discuss is distance. Time and distance are very, very similar. If you take distance, 1 kilometer equal to 1000 meter, and 1000 meter is 1 kilometer. If someone asks what is 2 kilometer, and the same that cross thing, cross method we must apply. For example, 1 kilometer equal to 1000 meter, we all know. Then what is then how many meters is 2 kilometers as just 100 in 1000 into 2, which is equal to 2000 meter. And this is very, very important when we come to speed. Here, you see, speed is what? Speed equal to distance by time taken. That is, speed is if speed is represented in kilometer per hour, but in the question we are asked to find represent the speed in meter per second. Then what you must do is multiply kilometer per hour into 5 by 18. Okay, for example, the speed is given as 18 kilometer per hour. Then we must multiply. Then the question is, then someone asked the question, what? How will you represent this 18 kilometer per hour in meter per second? Then you must multiply 5 divided by 18. So 18 will cancel. So we get 5 meter per second. The similar way, when you ask to convert meter per second to kilometer per hour, we must multiply that meter per second value into 18 divided by 5. And friends, you see here, we should not get confused over here. So, because some people will multiply kilometer per hour, some people will multiply kilometer per hour into 18 by 5. So the entire answer will go wrong. So for this, I will give you a small tip. See here, kilometer per hour is a big value and meter per second is a small value. You see here, we are converting a bigger value into a smaller value. So bigger value into smaller value. So we must multiply. So the numerator should consist only of the smaller value. Which is the smaller value here? 5 or 18. 5 is the smaller value. So kilometer per hour into 5 by 18. Similarly, see here, meter per second. We are converting a smaller value into a larger value. So the numerator should consist of a larger value. Here, meter per second into 18 by 5 is will give kilometer per hour. Okay, then we solve a small problems. Here 60 kilometer per hour is given. That is, suppose a car is traveling in 60 kilometer per hour. Then what is asked is this: for 5 kilometer per hour, what? 1 minute. Okay, for 60 kilometer, the for 1 hour the car is traveling 60 kilometer. For 5 hours, how many kilometer it will travel? The same cross method. For 1 hour the car is traveling 60 kilometer. For 5 hours, it is 5 into 60, which is equal to 300. If you put x here, x equal to 5 into 60, which is equal to 300 kilometer. Okay, then for half an hour, how many kilometer it travels? Simply by logic itself, we can say for 1 hour is 60 kilometer, means for half an hour it will be uh, 30 kilometer. So if you don't know this logic, you must but you not to but if you want to get for half an hour, what you do is simply use again this cross method. You put 1 hour equal to 60 kilometer, for half an hour x kilometer. So you multiply x equal to 60 into 1 by 2, which you can get 30 kilometers. Okay, and this is very, very important. If you are making note, please put an important sign here, as many people will make mistake only in this place. So the question may be very, very simple, but if you make mistake here, the entire sum will be collapsed. Okay, see here, 60 kilometer per hour. Suppose you take a car is traveling at 60 kilometer per hour, is reduced by 20 kilometer per hour. That is, you are traveling in a car 60 kilometer, traveling in a car at a speed of 60 kilometer per hour. Then your speed is reduced by, then what happened? Suddenly a bus or any traffic jam came, so you are reducing the speed by 20 kilometers per hour. So at that time, what you must do is you must subtract 60 minus 20, 60 kilometer per hour minus the rate, how much speed you have been reduced, that is 20 kilometer per hour. So the resultant speed will be 40 kilometer per hour. Okay, and in the other case, you see 60 kilometer per hour, a car is traveling at 60 kilometer per hour and the speed is reduced to 20 kilometer per hour. Remember friends, here it is by, here it is 2. Suppose you are traveling in a car, suddenly a dog or a cow um, crosses the road, suddenly you are applying the brake, so suddenly it is reduced to 20 km per hour. That is, you are traveling in 60 km per hour, suddenly you are reduced to 20 km per hour. Here you should not subtract the 60, your original speed 60 km per hour is turned to 20 km per hour, and this is very very important, which you must make a note of it. Again I'm saying, it is a car is traveling at 60 km per hour and the speed is reduced by 20 km per hour. That is 60 km per hour. You are reducing the speed to 20 km per hour. That is 60 km minus 20 km, which is equal to 40 km per hour. And here 60 km per hour, and you are reducing the speed to, here it is by, it is 2, reduced to 20 km per hour. And what you are doing is 60 km to 20 km hour, and the resultant speed will be 20 km per hour. Okay, and this is also most important. This is called as relative speed. Suppose assume that you are traveling in a train and you have got a window seat. Suddenly your train is traveling at some speed. Okay, and suddenly you see through a window and another train is coming opposite to you, and suddenly you are the observer experience that the train which is running parallel and is opposite to you is moving in such a high speed. Okay, after the train had passed you, and you can see and you can see your original speed of the train, that is you are going normally, but at that instant the train crosses you, you may experience some drastic amount of speed increase. That means when when you are traveling in a car, when you are traveling in a bus, or when you are traveling, when someone is coming opposite to you, as observer how you feel is that their speed and your speed will get added. That is the the object which you are going, that is the train which you are going, and also the train which is coming opposite to each other, both their speed will get added. Suppose, see here, when you traveling in a train which is running at 40 kilometers per hour, and again you have got a window seat, and another train which is also running at a speed of 40 km per hour parallel to you. Then if you see through a window, you may see, you may not feel that the train is moving. It may be seems like it is a standstill. What is happening is that as observer how you will feel is that the your train speed and that train speed gets subtracted. That is 40 km per hour minus 40 km per hour is, which is equal to 0 km per hour. And this is very very important. If it is opposite means you must add the speed, that is called relative speed. When it is same direction means you must subtract the speed. And here the average speed. Average speed is equal to total distance by time taken. Mostly people won't ask much problem on average speed, but you must know. Okay, I hope you understand. Okay, let me solve some problems. See here, what they are given. Speed of a Speed of a car is 72 km per hour. The distance covered by the car in 5 seconds. Here you see, this is a simple problem using the formula speed equal to distance by time taken. And what they are asking, the distance covered by the car. The distance they are asking, distance equal to, you must cross here, speed into time. That is, what is the speed they are given? 72 km per hour. What is the time they are given? 5 seconds. Now friends, you see here, the speed is in 72 km per hour, but the time which they give is 5 seconds. Then what you must convert? Either you can convert this seconds into hours, or you can convert the hours into seconds. So mostly it is easy to convert this kilometer per hour into seconds. Okay. So what I said, in kilometer, if it is in kilometer per hour, if you want to convert in meter per second, you want to multiply 5 divided by 18. Why 5 divided by 18? Because you are converting the higher value into a lower value. Okay. So it is, the numerator should have only the lowest value. That is 5 divided by 18. So 72 into 5 divided by 18 will give 20 meter per second. Now the time, now it is, we have converted into seconds. Now substitute here, distance equal to speed. Speed is what? 20 meter per second into what is the time? 5 seconds. Now if you cancel the second and second, you'll get 20 into 5, you'll get 100 meter. So simple, right? Okay, let's move on to another problem. And speed of a cycle is 5 km per hour. It crosses a bridge in 15 minutes. The length of the bridge in meters. Okay. just like the previous question. Now they are given speed is 5 km per hour. Then then the time they are given in minutes. So they are asking the length of the bridge in meters. So we must convert both of this. So first we convert the speed equal to in kilometer per hour. We want to convert into meter per second. Okay, it is 5 into 5 divided by 18, which we get 25 by 18 meter per second. Then time, then time in 15. 15 means, then in 15 minutes how many seconds is there? 15 into 60, which is equal to 15 into 60 seconds. Let's keep aside like this. Then then what is the distance? Distance equal to speed into time. You see 15 into 16 seconds into 25 divided by 18 meter per second. Now that second and second will cancel like this. Okay, and if you do simplification you will get the distance 1250 meter. Okay, so simple, right? Okay, let me move on to another problem. And this problem, if you see here means, see, first of all read the question. Car speed is 40 kilometer per hour, can cover a distance in 9 hours. How long it will take to cover the same distance at 60 kilometer per hour? This is a very simple question. See, in competitive exams, uh, if you put like this in a normal conventional manner, it can take some more times. Suppose it is easy sum, so it takes around some 1 or 2 minutes. But if it is a very big sum, and for each and everything you are calculating like this means, it will take very much time, and you may not be able to complete your test in the particular time. Okay, so first let me solve this sum in a conventional model. Then what they are asking is distance. So sorry, time they are asking. They are given the speed. Sorry, they are asking the distance, and they are given the time. So distance equal to speed into time, 40 into 9, which is equal to 360 meter. Okay, eh, for 40 kilometer hour, for 40 kilometer speed, in 9 hours the distance covered is 360 kilometer. Then what is the time needed to cover the same distance when the speed is at 60 kilometer per hour? Then simple, you know the time equal to distance by speed. We have found out the distance, and we have found out the, and we know the speed. This is given in the question, so substitute we will get 6 hours. Okay, this is conventional method. Let me teach you some tips so that, wait a second. Okay, let me teach you a small trick. See here, a car is traveling in 40 kilometer per hour. Then how much kilometer it will travel in 1 hour? 1 hour equal to 40 kilometer. See, in the question it is given us 9 hours. So for 9 hours it will travel 9 into 40, which is equal to 360 kilometer. See how easily we had got that answer. Instead of just putting the formula and substituting the answer, we are just found out in just a fraction of seconds. Okay, then come to the question. How long it will take to cover the same distance at 60 kilometer per hour? See, the speed is equal to 60 kilometer per hour, and the distance we know is 360 kilometer. And what number you should multiply to get 360? This is simple, that is 6. What is 6? 6 is in time, because it is speed, it is time, it is distance. Distance equal to speed on time. So this is a shortcut which you can apply anywhere instead of doing this much big things. Okay, Manish, it is clear? Manish, yeah, shall I continue? Okay, okay. Should we move on to the next question? See, this is a very interesting question. See here. Kamal left for the city B to A at 5:20 a.m. He traveled at a speed of 80 km per hour for 4 hours 15 minutes. After that, the speed is reduced to 60 km per hour. The distance between A and B is 350 km. At what time did Kamal reach city A? See here, then first you must know what is the given data. See here, Kamal left the city from city B to A at 5:20 a.m. He left the city at 5:20 a.m. early morning. He traveled at a speed of 80 km per hour. Speed is given as 80 km per hour. For how much time? 4 hours 15 minutes he have traveled. 15 minutes he can convert it into 15 into 4.25 hours. Okay, and after that the speed is reduced to 2. See here the word 2 is very important. As we discussed earlier, reduce to 2. Reduce to 2 means you should not subtract 80 kilometer per hour speed is reduced to 60 kilometer per hour, and now he is traveling at 60 kilometer per hour. The distance between the city A and B is 350 kilometer is given. What time did Kamal reach city A? See, it's very simple. See here. Now, speed is given as 80 kilometer per hour. Time is 4 hours 15 minutes. Then for the total distance is 350 kilometer. But for 4 hour 15 minutes, how much distance they have traveled? We have to find out. See here, the normal. It's a very normal convention, not a normal conventional method. It's a very simple method. See, it's, hello? Yeah, புரியல. Okay, okay. See here, the speed is 80 kilometer per hour and the time is 4 hours 15 minutes. Okay. Now see here, distance equal to speed into time. The speed is 80 kilometer per hour and the time is 4.25. See, for 80 kilometers traveled in 4 hours, which is equal to 80 kilometer traveled in 1 hour is 80 kilometer. For 1 hour, he travels 80 kilometer. Then for 4 hours, how much kilometer he will travel? 80 into 4, which is 320 kilometer. Okay. Then you must get this 15 minutes. Okay. How we want to find out? How we shall find for half an hour. Then if 1 hour, if he travel 80 kilometer means for half an hour, how much kilometer he will travel? 40 kilometer. We know. And for 15 minutes, that is half of this half an hour, he will travel 80 into 1 80 into 1 by 4. He travels 20 kilometer. So if we add this 320 plus 20, which will give us 340 kilometers. So instead of doing this conventionally, it will take a lot of time. You must multiply this and you must get the answer. We shall do it in simple mind calculation itself. See here, the distance traveled in 4 hours 15 minutes is 340 kilometer. Okay, the total distance given is 3 hours 15 minutes. 3 total distance is 350 kilometer. See here, what is the remaining distance? 350 minus 340, which is equal to 10 kilometer. That is the remaining distance. Now you must find out the time he traveled at 10 kilometer. Now, if you see in that question, after 4 or 15 minutes, the speed is reduced to 60 kilometer per hour. Okay. Now see here. Then for 60 kilometer speed, what is the time to travel 10 kilometer? That is our aim. So see here, time equal to distance by speed we know. Then what is the distance? The remaining distance is 10 kilometer. For the remaining distance, how much kilometer did he travel? How much speed did he travel? 6. That is 1 by 6 hours, which is equal to, if we convert it into minutes, means 1 by 6 into 60, which is 10 minutes. Now this is a normal conversion. 60 kilometer in 1 hour, that is 60 kilometer equal to 60 minutes. We cancel this, then he travel 1 kilometer in 1 minute. Then in 10 kilometer, how many minutes he travel? So 10 into multiply 10 on both sides, we'll get 10 minutes. Okay, or you can do the normal cross method. If you put x here, and you can get easily, you can get 10 minutes. So now you must add. At what time did he started? He started at 5:20 a.m. Okay, 5:20. For 4 hours 15 minutes, he traveled at 340 kilometer. Okay, then for another 10 minutes, for another 10 kilometer, he traveled 10 minutes. If you add both the, if you add three data means 5, 4, 9, and he reached the destination, that is city B, in 9.45 a.m. That is 9.45 a.m. Friends, do you understand? Manish, it's clear? Yeah, yeah, I'm going in a normal speed, right? Okay, okay, okay. Let me solve one more. Manish, please turn off your mic. Okay, thank you. Okay, let me solve one more problem. See here, two friends starting from a place, one by a bike and another by a car. The speed of a motorcycle, that is bike, is 30 kilometer per hour, and that of the car is 24 kilometer per hour. The first one take 6 hour 12 minutes. Then what is the time taken by second one? So here the similar to the previous question. See, first we must understand the question before solving the problem. See here, two friends starting from a place. There are two friends. One is starting from a place with his bike, and another one is starting from his place with its car. So the speed of the bike is 30 kilometer per hour, and that of the car is 24 kilometer per hour. And the person who go by bike taken 4 hour 12 6 hours 12 minutes. Then what is the time taken by second? So our aim is to find the distance they have covered. Okay, we are not going to solve it by in the conventional method. We are just going to solve it by normal main calculation. See here, for 30 kilometer 1 hour, one, this is for bike. For one for 1 hour, the person goes by bike travel 30 kilometer, that is 30 kilometer in 60 minutes. If we cancel this, it travel 1 kilometer in 2 minutes. Okay, keep it aside. Now see here, 30 into 6, which is equal to 180 kilometer. That is for 6 hours. Yeah, blur இருக்கா? Is the screen is clear? Clear? Okay. Manish, shall I start? Yeah, okay. Thank you. See here, friends. In 30 into 6, that is for 6 hour, that is 1 hour he travel 30 kilometer. In 6 hour he travel 30 into 6 is kilometer. And for the rest of 12 minutes, how many distance he covered? See here, it is for 2 minutes he cover 1 kilometer. Then for 12 minutes he cover 6 kilometer. If you multiply 6 on both sides, you can get 6 into 2, which is 12 minutes, which is 6 kilometer. That is for 12 minutes he traveled 6 kilometer. That is, if you add both of this, we can get 186 kilometer. So now the distance between the point A and point B we have known. Now we know the distance, we know the speed of the second person. Now we must calculate the time. See here, speed is 24 kilometer per hour, the person who goes by the car, and the distance is 186 kilometer. See, the time taken is distance by speed, which is equal to 186 divided by 12, which is 7.75. It's simple. Okay, okay. And we are going to see a very important problem. This type of problem you can see in most of the competitive exams. Okay, see here, a man goes to temple from his house at a speed of 3 kilometer per hour and return in 2 kilometer per hour. The total time taken is 5 hours. Distance between the house and the temple. See, the question looks pretty tricky, right? So but it is very very simple. See here, the total time is given. Okay, for going and coming, the total time is given is 5 hours. So the distance traveled by the man to go from his house to temple is 3 kilo in 3 kilometer per hour.
then we must find the distance between the house and the temple. So here we know the time equal distance by speed. For 5 hours, he traveled at a distance at 3 km per hour, and also he traveled the same distance and took at 2 km per hour. The total for this for going and coming, the total time he had covered is 5 hours. Okay, now we had found the relation from this question. Now if you solve this means, if you take LCM, it will become 5d equal to 30, and we shall get the distance equal to 6 km. Okay, it's very simple, right? Don't be get panic of this question, because if you understand, if you read 2 or 3 times, you shall easily crack the question. Okay, and this type of problem is very important in most of the competitive exams. This type of question is mostly asked. Okay, let me move on to the next question. Okay, see here, A and B travel the same distance at a speed of 9 km per hour and 10 km per hour respectively. If A takes 36 minutes more than B, the distance traveled by each is. Again, the same type of question, but in a different manner. Okay. So here, the speed of the A and B travel same distance. Okay, but their speeds are different. That is 9 km per hour and 10 km per hour respectively. Then their time is also different. A as a person takes 36 minutes more than B. Okay, we say if B takes 30 minutes to cover the distance, A takes 66 minutes. So the difference between the times of A and B is 36 minutes. Okay, in the previous sum we have discussed the total time. In the total time, the distance cover for going and coming. Here we are given the time difference. So the time difference is 36 minutes, and we know the time equal to distance by speed. We want to find out the distance. Let's keep distance as 6, and the speed of the first person A is 9, and the speed of the second person is 10. They are covering only the same distance, so we don't need to worry. The same distance x. So if we take LCM means, and we will get x equal to 54 kilometer. Okay, friends, and here we complete the basic concepts of time and distance with relative formula of speed equal to distance by time. Okay, now we are moving on to a very important topic. Manish, are you there? Clear? Okay. Okay. The second topic in time and distance which we are going to discuss is early, late, and usual problems. And this is also a very important problems in most of the competitive exam. They ask this problem. Okay, and we can solve this, but many people think it is very difficult, but it is very simple. Before looking into the problem, we shall just first read the question, see how it is. Okay, a man goes to his office at a speed of 30 km per hour and reaches 6 minutes earlier. See here, if a man goes at a speed of 30 km per hour, he reaches his office 6 minutes earlier. But if he goes at a speed of 24 km per hour, he reaches 5 minutes late. If he reduces the speed to 30 kilometers to 25 kilometers, he reaches 5 minutes late. The distance of his office is, okay. If you read the question, it looks somewhat difficult, but it is actually not like that. If you learn this simple trick and formula, it is very simple. See here, in the question, if there is a combination of late and early, and also the combination of early and late. See, in this question we have a word called early, and also in the same question we have the word called late. Okay, then if this is a condition, you must add the time. What you must add? This 6 minutes and this 5 minutes you want to add. Again, I'm repeating. In the question, if you see the word late and early, or early and late, that is opposite to each other. See, in this question, we have early 6 minutes early, and we have late. If this is the case, you must add that time. That is 6 plus 5 equal to 11.
Manish, turn off your mic. Okay, thank you. Okay, let us solve one more problem. See here, two friends starting from a place, one by a bike and another by a car. The speed of a motorcycle, that is bike, is 30 kilometers per hour, and that of the car to. Manish, it is visible.
ஹலோ பாலாஜி பாலாஜி
Yeah.
அவனுக்கு இது டேட்டா தீர்ந்துருச்சு, யூடியூப் ஸ்ட்ரீம் ஸ்டாப் ஆயிடுச்சு. ரூபேஷ் என்ன சொல்றான், ஒரு எப்படி ஃபர்ஸ்ட்ல இருந்து சும்மா ரிவைஸ் மாதிரி பண்ண சொல்றான். போன டாபிக் வரைக்கும், போன டாபிக் நீ ஃபுல்லா தான் எடுக்கணுமா?
புரியலடா.
நீ கொஞ்சம் ஒரு நிமிஷம், ஒரே ஒரு நிமிஷம் இரு. நான் சொல்றேன் எங்க இருந்து எடுக்கணும். பாலாஜி
இல்ல இப்போ ஓகே ஆயிடுச்சா?
இல்ல இன்னும் ஓகே ஆகல. ஒரு நான் டவுட் கேட்டேன்ல, அதுக்கு முன்னாடி சம் வந்து கொஞ்சம் சொல்லி தர முடியுமா?
சரி, ஓகே ஓகே, நான் சொல்லி தரேன். சரி, சால்வ் ஆயிட்ட சொல்லு.
வெயிட் பண்ணுங்க.
சரி, ஓகேடா. ஓகேடா.
பாலாஜி ஸ்டார்ட் செட் ஆயிடுச்சு. ஹலோ.
யா.
ஹலோ.
யா, சொல்றா. ஸ்டார்ட்டா? ஓகே ஓகே. Is my Manish, is my screen visible now? Hello, Manish, is my screen visible? Hello? Hello, Manish?
I start.
Okay, okay. Okay. Sorry for the inconvenience. Okay, let us continue with the topic. Then we are going to discuss about early, late, and usual time problems. Okay. We see here, first of all, before going into the topic, let me read a question. A man goes to his office at his, yeah,
Balaji,
yeah, yeah, Manish.
please explain some question 6 and please explain from question 6.
Please explain question 6. Okay. This question, a man goes to the temple.
From question 6.
Yeah, okay. Yeah, okay.
Yeah, from
Here,
that you should explain all the sums.
okay. A man goes to a temple from his house and at a speed of 3 km per hour and returns in 2 km per hour. The total time taken is 5 hours. Distance between the house and the temple. See, friends, this question looks tricky, but it is very, very easy and also it is very important. See, see here a man starting from this house and goes to the temple at a speed of 3 km per hour and return in 2 km per hour. Then the total time he has taken to reach from his house to his temple and temple to his house is 5 hours. So the total time is given. So here we know that time is equal to distance by speed. So time is equal to first distance, that is from house to temple, that is the distance. We don't know the distance, we have to find out the distance. Distance by speed at what kilometer? 3 km per hour. And the second distance from temple to the top of the to house. uh, from house to temple is the distance is x, means the same distance will be from the temple, will be from temple to house, which now what speed is traveling? Is traveling 2 km per hour. Now what is the question? It is asked distance between the house and temple. So we see here 5, that is time is equal to the first distance, that is from house to temple, and the second one temple from house. So if you substitute and if you take LCM, means we will easily get the distance by solving mathematically. Okay, is it clear? Moving on to the next question. Read the question. It is similar to that of the previous question. A and B travel the same distance at a speed of 9 km per hour and 10 km per hour respectively. Okay. If A takes 36 minutes more than B, the distance traveled by each is. First of all, understand the question. A and B are traveling and they are traveling in a same distance, but their speeds are different. See here, if A takes 36 minutes more than B, suppose if B is traveling 30 minutes, then what is the time taken for A to travel the same distance? That is 66 minutes. Okay, so the difference in the time is 36. That is A time minus B time equal to 36. Okay, we know from the speed distance time formula, time equal to distance by speed and distance one, that is the same, both are traveling same distance, right? So distance by speed one minus the distance by speed two, which is equal to 36. We know the distance, we keep it as x, we shall keep it as x. So x by 9 minus x by 10, which is equal to 36 by 60. Why are you repeating this, putting the 60 here? The speed is in kilometer per hour, but the 36 is in minutes, so we have to convert this minutes into hours. That is 36 divided by 60, which is equal to, we solve this, we'll get 54 kilometer per hour. Simple, right? And the last two problems, that is 6 and 7, are very, very important, and most of the question paper this sum will contain. Okay, another important topic, Manish. Okay, another important topic is early, late, and usual time. Okay, Manish, it is clear? Manish? Manish, is it clear? Manish? Manish, are you there? Manish? Manish, are you there? Bhupesh? Hello? Okay, let me move on to the next topic, which is very, very important. And most of the people think this type of questions are very difficult, but if you know the concept, means it is very, very easy. So this type of questions has come under the category of early, late, and usual time. Okay, first of all, let's read a question before learning the concept. A man goes to his office at a speed of 30 kilometer per hour and reaches 6 minutes earlier. And if he goes at a speed of 24 kilometer per hour, he reaches 5 minutes late. The distance of his office is. And if you look at this question, you may wonder, I cannot answer this question, but it is not like that. It is very, very simple. Okay. First of all, understand the question. A man goes to his office at a speed of 30 kilometer per hour. If he goes at a speed of 30 kilometer per hour and he reaches 6 minutes earlier to his office, and if he goes at a speed of 24 kilometer per hour, he reaches 5 minutes late. Okay, now they are asking the distance. Now we can do it in normal method, or we can substitute the formula. Okay, the important catch here is, if the question contains late and early together or early and together late, we must add the timing, that is the time difference we must add. Okay, see in this question, 6 minutes earlier and 5 minutes late, it contains early and late together, so we must add the timings, that is 6 minutes and 5 minutes, that is 11 minutes. Suppose in this question it has 6 minutes earlier and also 5 minutes earlier, so at that time we must subtract the time, that is 6 minus 5, which is equal to 1. First we'll solve this question in normal method, which is called as time chart method. Okay, first let's solve this sum in normal method, that is time chart method. See here, suppose that person daily goes to the office at 10 a.m. and now he travel at a speed of 30 kilometer per hour. Okay, 30 kilometer per hour, and he is earlier by 6 minutes. That is 9:54 a.m. itself he has reached the office. But if he travel at a speed of 24 kilometer per hour, he is late by 5 minutes. That is 5 minutes late. That is 10:05 he is reaching the office. So what is the time difference between 9:54 and 10:05? It is 11. So the time difference between these times is 11 minutes. So by the previous sum we have seen that, by time difference we shall easily solve this sum. Time equal distance by speed, we know the distance we have to find out, which is x, and the first speed is 30 and x is equal to 24, which is equal to 11. Why we are putting 60 here? Because it is given in minutes, but the speeds which are given in kilometer per hour. So to convert the minutes into hour, we are dividing it by 60.
So if we solve this, we'll get an answer 22 kilometer per hour. Okay, if this method seems difficult, I cannot put time chart because it is a time consuming more. So you can go for a formula method which is very easier than this. See here, formula is d is equal to del t into s1 into s2 by s1 difference s2. Okay, now see here, in the question it contains earlier as well as late. What I said, if it is early and late means we must add the timings. That is, he is 6 minutes late and it is and he is 6 minutes earlier and he is 5 minutes late. So 6 plus 5 we will get 11. Then you must multiply the speed and you must in the denominator we must subtract the speed. 30 minus 24 will get 6. And why we are putting 60 here, I already said the speeds are in kilometer per hour, but this 11 is in minutes, so we are dividing it by 60. So distance is equal to 22 kilometer. So simple, right? Okay, we shall solve and another question. In the denominator we must here subtract the speed. A person 30 minus 24 will get 6. And why we are putting 60 here, speed of 10 kilometer per hour, the speeds are in kilometer per hour, arrived at his office 6 minutes late when he is increased the speed by 2 kilometer per hour. See here, the important word is increased the speed by. That is, initially he is traveling at 10 kilometer per hour. When he increases the speed by 2 kilometer per hour, then what speed he is traveling now? He is traveling at 12 kilometer per hour. Okay, when he travels at 12 kilometer per hour, he reaches his office 6 minutes early. The distance of his office is, see here in this question, late is contained and early is contained. So what we must do? We must add both the timings. That is the del t, which is equal to 12. I mean, we know the speed is 10 into 12 and 10 minus 12 in the denominator. Why we are putting 60 here? Again, the speeds are in kilometer per hour and the minutes and 12 is in minutes. So to convert into hour, it is divided by 60. So the distance is 12 kilometer. See here, another question. By walking at a speed of 20 kilometer per hour, hello Manish,
சொல்லிட்டா
it is clear.
yes, it's clear and audible. Continue.
Yeah, okay. My screen is clear or blurred?
your screen share on பண்ணு off.
Yeah, is it yeah, is it coming now?
No, it was still not clear.
Coming now?
Now, yeah.
Yeah, okay. Yeah, shall I continue?
Yes.
Yeah. Question. Hello Manish.
சொல்லுடா.
Someone asked to repeat the question one now.
Wait. Yes. Repeat question 1.
Okay. See here. In the question, it is contained a man goes to his office at a speed of 30 kilometer per hour and reaches 6 minutes earlier. If he goes at a speed of 24 kilometer per hour, he reaches 5 minutes late. The distance of his office is, see here, we can do it in two methods. That is in normal method as well as in formula method. Normal method is time chart method. Consider daily he goes to his office at 10 a.m. But when today he is traveling at the speed of 30 kilometer per hour, he reaches 6 minutes earlier. That is, he reached the office at 10:54 a.m. But at the same time, tomorrow he is going at a speed of 24 kilometer per hour. He reaches 5 minutes late. That is, he reaches his office at 5 a.m. So if we subtract 9.54 from 10:05 a.m., we will get 11 minutes. So the time difference is 11 minutes. We know from the time distance speed formula t is equal to d by s. That is that is time equal to distance by speed. And if we calculate and if we substitute this, we will get the speed. And another thing is by formula method. Formula method is d is equal to del t into s1 into s2 by s1 difference s2. I again say, if the question contains early as well as the late, if you see this both word, then you must add the timing. And if the question contains early and early and late, and you must subtract the speed, sorry, subtract the time. See here in this question we have 6 minutes early and 5 minutes late, that is 6 plus 5 equal to 11, and and you must multiply the speed, and in the denominator s1 difference s2, that is speed 1 minus speed 2, that is 30 minus 24, and we are putting 60. Why we are putting 60 means to convert 11 minutes into hours. So distance is 22. Okay, is it clear now? Manish, it's clear? Is it clear for them? Hello, Manish? Hello, Manish? It's clear?
Clear. So,
Okay.
yeah, continue.
Okay. See here. Moving on to the next question. A person moving in a speed of 10 km per hour arrived his office 6 minutes late. When he increased the speed by 2 km per hour, he is 6 minutes early. The distance of his office is, see here, increase the speed by, when he is increased the speed by 2 kilometers, that is 10 plus 2, which is 12 km per hour. Suppose it is given as he is increased the speed to 2 km per hour means, then it is 10. Now the speed will be 2 kilometers, but here they are given increase the speed by, increase the speed by means 10 plus 2, which is equal to 12 kilometers per hour. Now we substitute in the formula. What is del t? In this question we see see both the late as well as early. So 6 plus 6, which is equal to 12. If we see late and early or late, means you must add the time, and if late and late or early means you must subtract the time. So see here. Yes, we had substituted 12 here. So we multiply the speed, and in the denominator we had subtracted the speed. The 60 is for converting this 12 minutes into hours. We will easily get the distance. Easy, right? Moving on to the next question. Here, a boy walking at a speed of 20 km per hour reaches school 30 minutes late. Then he increased the speed by 4 km per hour, but still he is late by 10 minutes. Find the distance of the school. See here in this question, late and late is there. Now what we must do? We must subtract the time. See here it is 30 minutes here and it is 10 minutes here. We must subtract the time. So what is 30 minus 10? We will get 20. Then the initial speed is 20 and the speed is increased by 4 kilometer means 20 plus 4, which is 24 kilometer. See here 30 minus 10 into 20 into 24 by 20 minus 24, 60. We are getting 40 kilometer, and don't worry about this 20 minus 24 equal to minus 4 and all, because we are dealing with only three parameters. One is speed, one is, and another one is time, and another one is distance. And no one will not represent I have traveled minus 10 kilometer, or my time is minus 10 o'clock, or my speed is minus 10 kilometer per hour. And if you get minus in your answer, just neglect the minus and put only the values which you have obtained. Okay, is it clear? Okay. Another sum is, it's not like a previous sum, late and early, it is usual timing. See here, walking 6 by 7th of his usual speed, a man is 12 minutes late. Okay. The usual time taken to cover the distance by him is, see here, understand the question. Okay, suppose if you don't understand the question, what you must do is read twice or thrice. Okay, I'll read it once again. Walking 6 by 7 of his usual speed, a man is 12 minutes late. Okay, a man is walking daily, you'll walk at a usual speed. Let's consider the speed as x. But if you walk at the speed 6 by 7th of its usual speed means, and he is 12 minutes late. Okay, now the late time minus usual time, which is equal to 12. The time difference is 12. Again, I'm insisting you, the time difference problems are very, very important. And if you practice more and more problem means, it is very easy to clear this type of question. See here, in the question, they are given 6 by 7th of his usual speed, but we need time. We know that speed is inversely proportional to time. Then the speed is given as 6 by 7th. And what is the time? If 6 by 7th of a speed means, then the time will be 7 by 6 of its usual time. So 7 by 6 of x minus x, which is 7 by 6 of its usual time, minus the usual time, which is equal to 12. That is, if you cancel this, you will get x equal to 72. Okay, is it easy? Is it right? Anyone has any doubt in this early, late, and usual problems? Manish?
No one has a question.
Yeah, it is clear. Shall I continue to the next topic?
Yeah.
Yeah, okay. Yeah. Next type of problem which we are going to deal is that chasing sums. Chasing sums are very, very important. If the question paper setter is asked to set a question paper in a very difficult manner means, and he will definitely include this sum in his question paper. So there are two methods of solving this sum. One method is normal method, that is equating method, and another one is formula method. And my personal advice is don't use formula for this method, because the value which you are going to substitute sometimes may go wrong. So I I advise you to use only the normal method, but I also teach the formula method also. So let's get started. See the question. A thief spots a police 100-meter away and chases him. Okay. If the police take a chase immediately, then how far would the thief have run before he is overtaken? The speed of the policeman is 10 kilometer per hour, and that of the thief is 8 kilometer per hour. First of all, understand the question. A policeman is here and a thief is here. Okay, and the thief spots a policeman 100 meter away. Then the thief start running. Definitely the thief won't run in this direction. Definitely he will run at the direction away from the policeman. Okay, then the thief running at a speed of 8 kilometer per hour, and the police give a chase. Okay, the police give a chase. See here, the speed of the police is 10 kilometer per hour, which is higher than the speed of the thief. Definitely the police will catch the thief at some point. Let us consider at that point. This point as police catches the thief. Okay, the distance we keep it as x. Now, now what is the catch in this question is the time taken by the police to catch the thief and the time taken by the thief to caught by the police are same. Okay, now you must equate the time. That is called equating method, where you must equate the time. See, in most of the question, time difference question and in equating question, mostly we will be equating only time. In some of the questions only we will be equating the distance, or we will be equating the speed. Mostly 90% of the question will be such a way that we must either subtract the time, or we must either add the time, or we must either equate the time. Okay, see here, time taken by the policeman, that is distance by speed, and the time taken by the time taken by the thief, and the speed of the thief. That is, what is the time taken, what is the distance traveled by the policeman to cover here to here? That is from this place to this place to catch the thief. That is 100 plus x. What is his speed? 10. What is the distance traveled by the thief to this point? That is x. That is x by what is the speed of the thief? 8. So if you substitute this, you will get 400. See the important very which we must hello. இல்லடா.
டேய், என்னடா பண்றீங்க?
Hello, Manish.
Continue.
Sorry for it. Okay. The second we are going to follow is that formula method. D is equal to del T into A by A difference B. So why I asked you not to use this formula method is that we must correctly substitute the value of A and correctly substitute the value of B. If we wrongly substituted the value, and the answer may go wrong. See, what is the important thing I said in this question is, remember, read the question. How far the thief has run before he is overtaken by the police? See, the question is on the thief. If the question is on the thief, we must find only this distance. Okay, what is the distance traveled by the thief? Okay, if the question is on the police, for example, then how far the police would have run to catch the thief? If the question is on the police, if the question is on the person who is chasing, we must calculate 100 plus x meter. For example, if we have calculated x equal to 400, why we stop the answer here? Because why we stop the answer? Because the question is on the thief, not on the police. For example, if the question is on the police means we must find the value of x as well as we must find the this total distance, that is 100 plus x, that is 100. What is 100 plus 400? Which is 500 meter. Okay, the same way when it comes to formula, what is the value of a means in which person the question is put on. For example, in this question you see here the question is put on the thief, put on the thief. So what is the speed of the thief? It is 8 kilometer per hour. So we must substitute 8 here. Then 8 by 8 minus 8. Sorry, 8 minus 10. Okay. If the 97 comes means just neglect. That is not no need to consider that. Then what is the distance between the delta is the distance between the thief and the police, that is 100 meter. That is d is equal to, if you simplify this, you will get d is equal to 400 meter easy, right? But my personal advice is to use this equating method. This is also as simple as this. Okay. Second question. A police constable follows a thief who is 200 meter ahead of the constable. If the police, if the police and the thief, if the speed of the police and the thief is 8 kilometer per hour and 7 kilometer per hour respectively, the police would catch the thief in. Okay, now see here, the question is put on the head of police, the person who is chasing. Now normally this is the police, this is a thief, and the distance between them is 200. When the thief saw the police, the thief started running to the point, and now the police catches the thief at this point. We must find what is this distance. Okay, now TP is equal to TT, that is time taken by the police, which is equal to the time taken by the thief. Now distance by speed. What is the distance traveled by the police? 200 plus x divided by what is the speed? 8. And what is the distance traveled by the thief? X. And what is his speed? 7. So if you simplify this, you will get the value 1400 meter. We should not stop the question here. Why? Because the question is put on the head of police. We have calculated only the distance here. We must calculate how much distance the police traveled to catch the thief. That is what they are asking. That is, we had found out 1400 and we must add this 200 also, so that we will get 1600 as the total distance. Okay, in this question they are also asking that if the speed of the police and the thief is 7 kilometer per hour, the police would catch the thief in. In some of the question, they will ask the distance. In the previous question, if you see me, they will ask only distance. But in this question, they ask time. They don't give time directly, but in the option they will give time. What we must do is you have to find distance by our normal procedure, and we know the time equal to distance by speed. What is the distance? 1600. What is the speed? 8 kilometer. And now also we must put 8. Why we are putting 8? Because the question is on the police. Okay, then if we normally substitute by converting this kilometer per hour into meter per second, we will get the answer, and the answer is in 12 minutes. Okay. Okay, and you can also solve this question by normal formula method also, but the important thing is whom the question is put on. If the question is put on the person who is being chased, then put a. When the question is put on who is chasing, put a value here. Okay, and here we are completing the basic 3 concepts about distance and time, and next we are moving on to the very important topic, that is problems on trains. Manish, it is clear? Any doubt is there?
No doubts.
Problem. This is very important, and it is also very easy when compared to the previous ones. Okay, problems on trains. Okay, but just a normal problem. A 10-meter long train is running at a speed of 30 kilometer per hour. Find the time taken to cover the initial portion of the train. For example, a train is here, and it, for example, a train initial portion, that is the engine is in the phase X. What is the time taken by the train's last compartment to reach that phase? Okay, they have given the speed and they have given the distance of the time. Then what is the distance travel? That is the length of the train is the distance traveled here. Okay, so here we know the speed and we are converting into meter per second, and we are getting the distance, and we have given the distance. Time equal to distance by speed. Distance is 100 and the speed is 30 into 5 by 18.